Okay, 13a, we have a velocity time graph. So, a vehicle which begins at rest at point P moves or begins to move in a straight line. For the first 4 seconds, the vehicle moves with a constant acceleration of 0.75 meters per second squared. For the next 5 seconds, the vehicle moves with a constant acceleration of minus 1.2 meters per second squared. The vehicle then immediately stops accelerating and travels a further 33 meters at constant speed. We want to draw a velocity time graph for this journey. So, for the first 2 parts of the journey, the formula that we are going to use is this, where v is final velocity, u is initial velocity, a is acceleration, and t is time in seconds here. Okay, so for the first bit, the vehicle begins to move with a constant acceleration of 0.75 meters per second. And that happens for 4 seconds. So for this bit, our initial velocity is 0. So v is 0 add 4 times 0.75, and that's going to give us 3 meters per second. So our first point to plot is 4 seconds along with a velocity of 3. So that point there. Okay, for the second part, we're told for the next 5 seconds the vehicle moves with a constant acceleration of minus 1.2. So for this part, our initial velocity is 3 meters per second. So v is 3 minus 1.2 times 5, which is 3 minus 6. So that's going to be minus 3 meters per second. So the next point we need to plot is 5 seconds later. So that's it, 9 seconds, and then minus 3. Cool. Okay, now for the final bit, we know that we travel a further 33 meters at constant speed. So, even though our velocity is negative, which, by the way, is going to be because the vehicle is going backwards, even though our velocity is negative, our speed is positive. So we need to work out what time it's going to take to travel 33 meters at 3 meters per second. So speed is distance over time. Time is distance over speed. So we got 33 over 3 is equal to 11 seconds. So the final point we need to plot is 11 seconds later at the same speed. So that's going to be 20 minus 3. Okay, so now I just need to join up these points using straight lines. Okay, so that is our completed velocity time graph. Okay, and then part B wants us to find the distance of the car from point P after 20 seconds. So, on our graph, there are two different types of velocity happening. There's positive and negative. So, positive velocity means we moved forwards and negative velocity means that we moved backwards. So, looking at the graph, first of all, we can see we got this triangle, first of all, where we were moving forwards. Now, the line crosses 0 at 6.5 seconds. So, everywhere inside of this triangle, we were moving forward. So, we need to work out the area of the triangle. So, area of a triangle, space times height, divided by 2. So, let's do 6.5 times our height of 3, and then divide that by 2. Use your calculators. 6.5 times 3 is 19.5. Divide that by 2 is going to be 9.75. So, we travelled 9.75 metres forward. Let's work out how far we travelled backwards. So we already know in the rectangle here, we know that that was 33 metres. So we just need to work out the area of this triangle. Now the length at the top is 6.5 to 9, which is 2.5. So 2.5 times 3 divided by 2 is 7.5 divided by 2, which is 3.75 meters. So in total, we travelled 33 and 3.75 meters backwards. So we've travelled 36.75 meters backwards. Now remember, the car is moving in a straight line, so it's going to have gone forward from P, but then when it's gone backwards, it's also gone backwards through P. So what we need to do here is distance from P is gonna be 9.75 minus 36.75. Now that's going to give us an answer of minus 27 meters. But the reason that's negative is because we are behind point P. So distance can't be negative. So we are 27 meters from P. Cool.